This is Mr. Von Neumann. In this tutorial of part 2, we are going to continue evaluating our exoplanet of GJ and figure out how far away it needs to be away from its star. In our solar system, the distance that the Earth is away from the Sun is called 1 AU. So this new unit of an astronomical unit, or AU, is the distance of the Earth to the Sun, which if GJ's star was exactly the same size as our Sun, we'd want to have that planet be 1 AU away. But that Sun, its star, is not the same as our star, and so we're going to have to make some adjustments. So GJ is going to be 41% smaller than the Sun, so it'd be about that size compared to the Sun. So since it's smaller, if the temperature were the same, but yet it's smaller, we couldn't be at the same distance away. It'd be too cold. We'd have to get closer to it because it's smaller. Since it's smaller by 41%, we're going to get 41% closer. So first, we just have to figure out what 41% of 1 is, which is, that's very easy, because it's just going to be 1 minus, well, first you have to actually figure out what is 41% of 1. So in this case, it would be 1 times 0.41, and that's going to give you 0.41. Now the next one we do won't be that easy because instead of 1, it'll be a different number. But once you've got this is 41% of the 1 AU is 0.41. Now just subtract that from 1, and that's going to give you 0.59. So by subtracting that 41 away from the 1, now we know that we're going to be at about 0.59 for that planet. That's our position. So that planet is going to be at 0.59 AUs. That's the first position that we came to by calculating the size. So in the analysis, we would say that since GJ is 41% smaller, it would have to, since GJ's star is 41% smaller, it has to move, the planet has to move 41% closer to stay as warm as Earth. So it would have to be at 0.59 AU. Now the next step will be to figure out how close or far based on the temperature. So for the next step, the temperature is 33% colder. So again, we're going to have to get closer. If it was hotter, we'd have to get farther. But in this case, we got closer because it's smaller, closer because it's colder. So now we need to figure out what is 33% of this position, 0.59, and move that much closer. So 0.59 times 0.33, that was the 33%, turned back into a decimal, gives you, if you run that on the calculator, 0.19. So now we have 0.59 for this position minus 0.19, which is the 33% that we're going to take away from it, gives us 0.4. That position of 0.4 is going to be the final position that we need the planet to be at. So it would have to be at 0.4 in order to be as warm as Earth. So we go ahead and write that into our analysis, and that is the position we want it to be at to be like Earth. So since GJ's star is 33% colder than the Sun, we'd have to move another 33% closer. So it would have to be an additional 0.19 AU closer for a position of 0.4 AUs to be livable like Earth. And that is what we're trying to do in step 2 to get to that conclusion of where we want that planet to be livable just like Earth.